In section 7.5, we talked about similar triangles and indirect measurement. And indirect measurement is used when you want to find the height of something, but the thing you're trying to find the height of might be way too big to actually stand up and measure. For example, in number 2, the flight of the flagpole would be something that you couldn't just take a measuring tape to. Or usually like the height of a building. So if you look at number 1, it asks, how tall is Becky? Now, notice I have 2 triangles here, and I know that they're similar because we learned that if 2 angles in a triangle match with 2 angles or are congruent to 2 angles in another triangle, then those 2 triangles are similar. That being said, I can set up a proportion, whereas the height of the person matches the height of, the height of the mailbox. Move this up real fast. Okay, so the height of the person matches the height of the mailbox, and the bottom distance or the ground distance is going to match the ground distance over there. So when I set up my proportion, I'm going to start with my bigger triangle. So I'm going to go big triangle divided by the same location number is equal to, I have to go back to my big triangle, divided by the location that's matches that, okay? When you solve a proportion, you cross multiply and divide. So h times 4 is 4h. 3 times 7 is 21. And then you want to go ahead and solve that one-step equation. So divide both sides by 4. Divide both sides by 4. And 21 divided by 4 is h equals 5.25. And I can label this because my picture is labeled as feet. So what this is saying is I used my mailbox because I could measure the height of my mailbox. It's only 3 feet. I used my mailbox to figure out how tall Becky is by using indirect measurements and proportions. Okay. Now let's take a look at number 4. Okay, number 4 has 2 triangles as well. However, one of the triangles is hidden. So what I'm going to do is I'm going to take the smaller triangle here and redraw it. Okay, so there's my smaller triangle. And I'm going to label the smaller triangle the exact way that it's labeled in the picture. It's telling me that this height here is h, and if you look down here at the bottom, the entire length of the triangle is 20, but this small portion of it is 2. So if I take 20 and subtract these 2 feet, I'll get the height of my small triangle. So 20 minus 2, which gives me 18. Now I'm also going to draw the bigger triangle. Okay, and the bigger triangle has a height of 2.5 feet, and its length down at the bottom is that entire 20 feet. Now it does not have anything to do with this 2 feet. If you look and I cover everything else up, that 2 feet has nothing to do with the length of my big triangle. Okay, what it was there for is so that we can take 20 and subtract the 2 for the length of my small triangle. Now I want to go ahead and match up sides. So my height, or my h, is going to match up with that 2.5. My 18 and my 20 are going to match up together. And I can set up a proportion to solve. So I'm going to start with my triangle on the left, and I'm going to do my height divided by 2.5, because that number is in the same location, is equal to, I have to go back to my original triangle I started with, 18, and then back to my bigger triangle. Okay. Cross multiply, h times 20 is 20h. 2.5 times 18 is 45. And then you want to go ahead and divide both sides by 20 to solve that one-step equation, and you get 2.25. We can label it because my picture's labeled as well.